All right. So far, what we have focused on is, pointing out that foundational ways of thinking about economic systems, sort of the Industrial Revolution through sort of over, World War II era of, rapid economic growth was, largely led by a fairly traditional view of economic systems, more laissez-faire views of the way in which businesses would operate. But of course, there were, instances of, significant government intervention in that particular time. So you had the trust busting era of the late 1800s, and through the early 1900s, obviously spurred on and in many respects kind of championed by Teddy Roosevelt. And then, of course, you had the second Roosevelt, FDR, who in his time in office did significant amount of breaking up of large businesses, into smaller ones. One of the problems with the quote unquote free market is that it does not stop itself from producing potentially inefficient outcomes, even from an economic perspective. So there's a lot of stuff that needs to be maintained in order for a market to be considered efficient. And one of the main assumptions, again, going back to those neoclassical assumptions, views of competitive markets, is that a competitive market has a lot of firms all competing with each other. Well, in a situation where you have market power, what ends up occurring is the economy starts to grow itself inefficiently, and too much economic power is assumed, usurped, however you want to think about it, by large firms. And then, of course, even perhaps more distressing, those large firms, by virtue of, seeing an opportunity, often become very politically powerful as well. We're dealing with this problem in this day and age. There's in the era of governmental lobbying, there's a tremendous amount of market power and a tremendous amount of money spent every year by large corporations to, write favorable laws, just like there are an immense amount of lobbying for polluting corporations to write in favorable environmental policy. I mean, this has really been sort of a history of a lot of federal agencies, in which they're created with very good intent. So the Environmental Protection Agency is created with very good intent, but under certain administrations and under certain EPA directors, there has been at times a fairly favorable business approach to environmental policies. So sometimes policy has been written in a way that specifically makes it fairly inefficient or ineffective at actually creating more positive environmental outcomes. It's ridiculous, I think, to a lot of us that these things occur, but they certainly do. So again, that sort of free market view has limitations even before you get into environmental issues, in just the sense that we're very concerned about things like market power. We consider market power what we call a market failure. And a market failure is a situation in which we cannot rely upon the market to produce the most socially efficient outcome. That in fact, the market, if left to its own devices, is going to produce a socially inefficient outcome. And in the case of a monopoly with market power, it actually is also economically inefficient. It's socially inefficient as well as economically inefficient. There's also issues related to things like information asymmetries, when information is not fully known. This matters not just for general consumption. If you're buying a used car, or if you're buying a product and you don't really know the quality of it, you could be taken by a snake oil salesman, for example. Or it could be, maybe people make bad environmental decisions because they lack information. Maybe we consume goods that are very environmentally damaging, in part because we don't know they're that environmentally damaging. And it's only been recent, for example, that you've heard any sort of notion that, the fashion industry, what specifically is often referred to as fast fashion, this extremely high productive way to think about the fashion industry, where you're constantly making new clothes. And the focus is really on cheap, cheap as possible. Spend as little money making the products as possible. This includes working conditions as well well as wages for your workers. And so, there's been a movement to educate people in terms of, what you're buying is really coming from circumstances that we don't think you would support. That's about, fixing an information asymmetry. And that certainly is true of environmental problems. I think people consume a lot of things absent-minded of the fact that it produces a tremendous amount of environmental problems. One of the things we'll talk about in this lecture, the last video of this lecture, is the aspect of coal ash. Coal ash is often something that poses significant significant environmental risk, for which there are economic uses of it, but we'll discuss why, even with the fact that it can be used economically, that doesn't solve the problem. And so we'll certainly come back to this notion of coal ash. Well, coal ash is produced from coal burning. And, every time you flick a light on in a house, if you get your energy from a coal-fired power plant, which, historically that was the majority of energy produced in the US. Over time, that's given way. There's still a lot of electrical grid systems that are supported often by some amount of coal burning, although that is being reduced, both for economic reasons as well as for some environmental policy reasons. And we'll certainly break open that in the next video. What we're going to sort of, put a lot of focus on in this course is the framing of economic problems as what we call externalities, and specifically negative externalities. So that, this sort of invokes the first law of thermodynamics, which says that, matter is neither created nor destroyed. And what that means is that, all that can happen is that energy can be transferred, right? That once something is created, it will exist in some form, but you may be able to transfer its energy through form. So you may be able to change the substance, but it's still going to exist in some capacity. And burning coal is a great example, right? So, coal comes from this geologic process, millions and millions and millions of years ago. Plant matter, animal matter, and geologic forces conspire to produce, coal. And, coal has many different forms. There's many different types of forms, but generally, what coal is known for is you can burn it and it produces a lot of electricity. So, you can burn most things. Some things, put off a lot of electricity or a lot of energy, or some don't. But coal is something that is a substance that, at least historically speaking, when you burn it, it gives off a fairly high amount of energy. And so you can harness that energy and you can use it to produce electricity. It's any sort of electricity generation is the same. It's about transferring some, energy from one source to another. So, natural gas is increasingly becoming a common way to provide electricity. And natural gas, of course, is burned for its electricity, just like coal is. Natural gas being significantly cleaner when you burn it than coal, certainly, although there are concerns over the actual extraction process of natural gas, and issues related to fracking and things like that. And then, of course, solar energy and wind energy. This is all about energy transference. Well, the thing is that markets don't really look at where energy goes after it's used for that specific economic purpose. So in energy markets, for example, they really don't care what happens to coal after you burn it. And the truth is that coal does not disappear after you burn it. So you burn it, and aside from the fact that it creates, pollution in the form of air emissions, both in terms of CO2 and methane, which often are found in coal, but also in the form of particulate matter. Coal is an extremely dirty substance, and when we burn it, it gives off a lot of energy, but it also gives off a lot of energy in a lot of different ways. Some of that is emissions of CO2 and methane, as I mentioned. Some of it is particulate matter, so literal physical pieces of pollution. And then in addition to that, coal also leaves behind coal ash. So if you've ever done any grilling, with charcoal, that it doesn't go away. The coal is diminished, so the amount of physical space it takes up in your grill certainly declines, but there's a lot of ash left over, and that's a byproduct of the coal itself. So, the fact that, matter is neither created nor destroyed is a problem for economic systems, because it knows how to deal with the the burning of the coal and how to charge a price for the electricity that enables a company to make money by burning coal, right? The market can sort of fundamentally do that, but the market doesn't recognize there's also this emissions, there's pollution, and there's this coal ash. And, you know, the truth is that historically we've had very little use for coal ash. Like I said, there's been some development of coal ash, you know, it's put into a lot of products. I don't necessarily know how useful it is to put into products. There's certainly some question about whether it's useful. I mean, it makes its way into cosmetics. It's used for agricultural fertilizer. You know, it's used for a lot of different reasons, you know, but at the same time, so much coal ash is produced that even though there are these economic markets where there's demand for coal ash, we burn so much coal that we have a surplus of coal ash, massive surpluses of coal ash, and all we know what to do with them is pile them up. It's all we can do about them. So if a company isn't able to sell their coal ash to someone and it isn't able to be used, it just piles up and piles up and piles up. And that's a really good example of what we would call a negative externality. So let's think about this in the sort of supply and demand framework. Again, we want to place everything in this course in sort of an economic way. So let's start with this idea that a market forms, a market for some product, and you know, all we're going to assume is that in addition to the normal functioning of a market, that this market also has a negative production externality. Specifically, that the production of whatever this product is produces what we were going to call social damage. Okay, social damage. Social damage is a byproduct of the market itself. It wouldn't exist without the market. And so the problem, of course, is that the market doesn't see the social damage. The market only sees its own willingness to pay, represented by the demand curve, and it only sees its own willingness to accept, which is represented by the supply curve. The demand curve is based upon utility functions. The supply curve is based off profit functions. As I mentioned in the previous video, the demand curve represents the marginal benefit of consuming goods, and the supply curve represents the marginal cost of supplying goods. And so you get this nice story to tell, which is that, you know, as long as the marginal benefit of a good is greater than its marginal cost, we should consume more of it. So if you look at every, you know, level of quantity prior to Q star, you'll see that the marginal benefit, or the demand, is greater than the marginal cost, the supply. And so this says that society does better if we increase our consumption in this direction. Of course, beyond Q star, we can see that supply is now greater than demand, so the marginal cost is greater than the marginal benefit, and so it's not economically useful for us to consume beyond Q star. In fact, it would be considered economically inefficient. And so laissez-faire economics, free market economics, would suggest that, you know, P star, the price produced by this market, is efficient. Again, go back to this idea of the market as pricing signals. So other markets that perhaps purchase this good are going to pay P star for it. And again, we're basing this on this notion of private value. This is the value to the people inside of the market, the consumers and the producers inside of that market. But like we said, this product produces a negative externality. It produces social damage. And what I mean by social damage is, let's imagine that this product produces some pollution and that we're able to quantify this pollution. And we're specifically able to quantify it in a monetary amount. So we're able to say that every time this product is produced, you know, and consumed, but specifically produced in this sense, every time this product is produced, it creates $3 worth of marginal damage, right? So every single time it's consumed, that's $3 in damage that occurs outside of the market. Okay, so we will refer to this as marginal external damage. This is damage that the market itself doesn't see. None of the decisions inside of the market are making decisions with that additional damage in mind. Everyone inside of the market is only focused on their own private value. They're almost explicitly ignoring this marginal damage which flows outside of the market. Now, you know, for now, let's just ignore the complications of quantifying, you know, pollution and the monetary value of pollution and things like that. We will tackle those subject matter later on. Let's just for now assume we can, and let's assume that we can literally quantify for every amount that a product is consumed rather produced, we actually have the monetary damage that is created outside that market. And this damage could be sourced from a lot of different places. You know, pollution creates health problems, as we've mentioned. And so part of this damage could be increased healthcare cost. Part of this damage could be loss of aesthetic value. Again, go back to that idea of there being an intrinsic value. You know, I mentioned that the river that I'm in right now, or the river that I'm beside in my video, is the Dan River in North Carolina. You may have noticed previously, I didn't mention this, that there is some sort of factory or some sort of plant. That in fact is a coal-fired power plant. That is a power plant which provides electricity to the surrounding region, and you'll notice that that power plant is literally on the river itself. This, of course, is because coal-fired power plants need a lot of water. They need a lot of fresh water for all sorts of reasons. And so a lot of, or even most coal-fired power plants are on freshwater rivers, freshwater lakes. If you're ever up around the Lake Michigan area, if you drive kind of, towards Michigan from Chicago, you sort of drive around the lake. That drive, you'll see all sorts of coal-fired power plants, which are right there on the shore of Lake Michigan. Because again, there's a need for fresh water. Fresh water is an input to the coal burning process. So you take all of those damages and we sort of compute their marginality, you know, every time this is produced, how much damage is created. This is labeled as the social supply. What I mean by social supply is that we're taking the private supply curve and we're adding to that private supply curve the marginal damage. Essentially what we're doing is we're adding the cost to the firms to produce the product, which is represented by the supply curve. We're adding that to the marginal damage created, right? So let's say normally the marginal cost of this product is like, let's say $15, then let's say again that marginal damage is $3. So instead of saying that the cost of the product is $15, we would say in fact that the true social cost of the product is $18, the $15 that it costs the firm to produce it, and then the additional $3 in marginal damage produced from the negative externality, from the pollution. So in other words, because the market would normally see P star, okay, $15, it reacts to that price. So all of the other markets that serve this market are going to pay $15 for the product, but we're saying that there's this additional $3. So every single time this product is purchased, that $3 is showing up in the form of damage. So it's damaging society, but it's not being compensated for by the consumers or the producers of the product. So it represents uncompensated damage. So it represents real economic cost, and real economic cost that is not being replaced by the market. So you can make this about a moral issue, or you could look at it strictly from the perspective of an economic problem, which is that uncompensated damage is fairly uneconomic. You can't consider a system that produces uncompensated damage. You can't really consider that system efficient if you care about individual outcomes. You could say, well, the system serves a greater purpose, and if some people are hurt, well, that's just the way it works. I mean, aside from being a fairly unpopular opinion, although I think a lot of people for some reason do hold that opinion, but it's not the majority of people that hold that opinion. But aside from that, it really doesn't make sense economically in a world where we sort of care that transactions are mutually beneficial, that if you expend resources, you get something for that expense of resources. Whereas if you face a negative externality, then what you're doing is you're paying for the negative aspects of that resource while not necessarily getting anything for it. And even if you are getting the product, even if you buy the product, you are still damaged by the negative externality. And so it reduces the value of the product to you, almost in the same way that it increases the true social cost. So we say that the social supply curve represents the true social cost of the product, which creates a new equilibrium. And we'll actually refer to this equilibrium as socially efficient. Socially efficient because it would be the equilibrium of the private demand curve and that social supply curve. The social supply curve being the supply curve which represents the additional cost of the negative externality. What this produces is a socially efficient pricing quantity. You'll notice that that's less than the initial market equilibrium or the private market equilibrium, and you'll notice the price is greater. So, inherent in this externality, framework is the suggestion that if we consider the additional damage created by a product, the external damage, if we consider it, when you place that into the supply and demand framework, it suggests that the private market is no longer efficient, that the private market, in fact, produces what we refer to as deadweight loss. Deadweight loss is the economist's term for economic inefficiency. And in this case, the deadweight loss exists because from a social perspective, the market is overproducing. Remember before I said, that we don't consume past Q star in a private market because beyond it, marginal cost is greater than marginal benefit, right? Now, notice what happens when we include the social supply curve. Notice now that the point at which that is true is much earlier and also at a higher price. So just from that perspective of consuming until marginal benefit is equal to marginal cost, if we include the additional marginal damage in the social supply curve, then this new equilibrium suggests that marginal benefit equals marginal cost at a smaller quantity. And if the private market is allowed to persist, it's going to produce this deadweight loss. And this represents real economic and social inefficiency. So in other words, the negative externality theory tells us that a private market will produce a socially inefficient outcome. And therefore, if our policy is structured to care about social efficiency, then negative externalities are a market failure. Because if we didn't care about, additional damage and all we cared about was growing the economy, right, then perhaps, that's fine for us. But in a world where in a reality where pollution matters and pollution, creates real costs and real damages, whether they be human health related or animal health related or, aesthetic reasons, then that represents real economic value potentially. We'll talk about this in the next video a little bit more, but again, the Dan River here in North Carolina, there's a reason why I'm using this picture. So this coal-fired power plant, which again was just stacking its coal ash, had a big spill. Basically, the coal ash broke off like a mountain formation, and tons of coal ash spilled into the river and were, of course, a dramatic environmental disaster. These sort of coal ash spills happened before. There was another one in Kingston, Tennessee, not that long ago. And these coal ash spills are especially problematic because the coal ash is so chemically burdened and it has so many different types of chemicals. So it gets into the groundwater and contaminates it. So a recent study looked at Texas coal-fired power plants, and they found that virtually every place where there's a coal-fired power plant in Texas, the groundwater is so contaminated that it can't be consumed by humans. So now, listen, if that's okay, if society is willing to disrupt every single underground water table below a coal-fired power plant just because they want coal-fired electricity, but I think a lot of people would look at that and say, look, that's an incredibly myopic view. And if we have any concern about future water needs, especially in a state like Texas, which is probably going to experience dramatic climate change effects, then maybe, building fewer coal-fired power plants or, looking at alternatives to that, in addition to, the climactic things, the fact that it's going to burden our water systems. But again, the market doesn't see the burden placed on water systems because it actively ignores it, right? The burden placed on water systems is this marginal damage, right? So we have to almost in hindsight say, okay, this market creates a negative externality. What does it look like if we include it? And when we include it, we can see again that we should consume less of it. So if this is coal, for example, not only should we consume less of it, but we should be paying a higher price for it. And this tends to be kind of a controversial opinion. This is where you start to lose people. A lot of people can say, oh, okay, I agree that maybe we should consume less of a product, but I don't want to pay any higher prices for things. But of course, this ignores the fact that that's precisely how you get people to consume less things in a free market, is the price of something goes up and we move up the demand curve and people consume less of something. So that's going to be it for this video. There is more additional commentary on negative externalities as well as positive externalities in the handout that I gave you for the class. So more information on this. But again, the basic idea here is I wanted to show you how we can frame this problem in an economic context. And the framework here is useful because we can specifically point to what the problem is. And the problem is that the market externalizes the externality. It doesn't internalize it. So when we force the market to internalize the externality, then what we get is this sort of symbolic way of showing that the private market is inefficient, right? And I say symbolic because, you know, this view looks like we're making some assumptions, or it looks like it would be difficult to do. Like, for example, how do we measure marginal damage? Is that even something that we can do? Well, you know, if this is pollution that creates increased healthcare costs, we can compute that, you know, or we can at least try to compute that. If this is damage that, you know, reduces the recreational value of a river, like the Dan River in North Carolina, then we can measure that, you know, right? There are various ways that we can measure environmental problems. There's always going to be some issue related to, you know, how do we measure intrinsic value? That's something that we should care about. But in terms of monetary values, we can do this. And so, you know, certain types of pollution, and we'll cover these types of pollution later in class, certain types of pollution, there's a potential for us to use the fact of the negative externality that I've shown you as a potential, you know, policy tool, specifically what we're going to refer to as Pigovian taxation, sometimes referred to as sin taxes. And basically the argument says is that if a market produces something you don't like, you should tax that market. So for example, if a market produces a negative externality, we can tax that market, and we might be able to achieve that socially efficient position that you see in the graph. The tax needs to be, you know, calculated in a way that it gets as close to marginal damage as possible. This is, of course, something that we'll talk about later when we actually talk about valuation methods, and again, how environmental economists take what seem to be immeasurable environmental value and at least try to estimate value in a way that makes it possible for us to consider these from a policy perspective.